All right, so this is still 3.6a, the chain rule, and I just finished part one, the intro. And now I'm just going to tell you the actual definition of chain rule. And here it is. So I want you to copy this too. It's the derivative of the outer function times the derivative of the inner function. All right, so there's our actual steps. So you're going to take the derivative of the outer function times the derivative of the inner function. So it's important that you are able to identify the inner function and the outer function. Now back to the previous example I did here, you might wonder, why would I want to go through all of this if I could just do it over here and get 6? The reason is, obviously, they're going to be a little bit more complicated, and we just wanted to show you a simple example. So here's the first example from your note insert. So it says y equals 2x minus 3 raised to the 4th power. And so if you really wanted to, you could use binomial expansion and multiply out 2x minus 3 to the 4th power, but that might take you a while, and there's also room for error with doing all the multiplication and addition and subtraction. So here's what we're going to do. We first have to identify the inner function and the outer function. All right, so I can see the inner function here is the 2x minus 3. So I'm going to let that be my u. So I'm going to say u equals 2x minus 3. And this is my inner function. All right, now my outer function is the parentheses raised to the 4th power. So I'm going to write y equals u to the 4th power. I'm going to take the derivative of each one. So this one's going to be y prime, or dy, right? So dy du equals, so this is 4u to the 3rd power. All right, and then over here, du dx equals a2. All right, so what I want to do is, if I put these back in, if I multiply these together, I get 4u cubed times 2, but I know what the value of u is. I'm just going to substitute it back in. So that's going to be 4 times 2x minus 3 to the 3rd times 2, or 8 times 2x minus 3 cubed. And that's my dy dx.